Okay, for this first study guide of the second semester, we go back to the chemistry stuff where we were doing chemical reactions and having to identify what the products were, the level 4. So quickly, I want to talk about writing chemical formulas again because you need that to be able to have the correct equations and balance the correct equation. So remember in your periodic table, you should have charges, but why we have those charges is remember everything in family number 1 has one valence electron. So they're going to give that one electron away, so they're going to be positive ones. Because if you give an electron away, you've got more positive charges than you do negatives. Family number 2 has 2 valence electrons, so they're going to give 2 away, and that's going to be a positive 2. Families 3 through 12 are the transition metals, have all sorts of different charges, and some of that comes down to information that you will learn in chemistry next year called the D block. Okay. Over here, family 13 is 3 valence electrons, so they're going to have 3 positive. Family 14 usually shares, except for when we get down to the metals, we notice that they have properties of having a 4 positive, or in the cases of the 2 down here, they can be 2 or 4. Okay. Family 15 has 5 valence electrons, so the nonmetals are going to take 3 to get to 8, or that full octet. The metals are going to give 3. Family 16 has 6 valence electrons, so they're going to take 2, so the nonmetals are all negative 2s. And family 17, the halogens, have 7, so they're going to take 1 electron to get themselves to the full noble gas configuration. And then family 18 is not going to combine, because remember the noble gases are full. They are not going to want to combine with anyone. So here's kind of a rundown again to remind you of what the charges mean. And then up here we have the polyatomics, which have their own charges. They are ions that are not complete. They're waiting for another charged piece to come in and put them together. So what we're going to do here is create a new slide and do a couple of these. So first of all, if I tell you to write out the chemical formula for calcium, we'll start with calcium chloride. Okay, so we know calcium's Ca, and we should know that chlorine, okay, because that's chloride when it's by himself, is Cl. So we're going to go back to the slide before and notice that calcium has a 2 positive charge, and chlorine being a halogen has a negative 1. So if this is a 2 positive and he's a negative 1, we think about how these guys would come together. If calcium has 2 electrons to get rid of and chlorine can only take 1, it takes 2 chlorine to take care of those charges that are being given away. So if we take the subscript 2 multiplied by the superscript negative 1, we get negative 2 electrons. That means 2 electrons are being pulled in. 1, there is no 1 there, but we recognize that there'd be 1 calcium times the 2 positive is 2 electrons being given away. This is the correct chemical formula for calcium chloride. Now let's keep with calcium, but let's add a polyatomic. So we'll go calcium phosphate. Okay, we know calcium's still a 2 positive. And phosphate, we notice it does not end in "ide", so it's not going to be an element, it's going to be a polyatomic. So let's go back to the previous slide and look up here for phosphate. And we notice that for phosphate, PO4, right here, 3 negative is phosphate. So we're going to come back, PO4, and he's a 3 negative. So calcium's going to give away 2. Phosphorus can take 3. So the closest way these guys can combine is by the use of 6 electrons. 2 and 3, closest number they have in common is 6. So how do I get to 6 here? It would take subscript 3 calciums, each giving 2. So 3 times 2 is 6 positive, so 6 electrons being given away. And it's going to take 2 phosphates, because 2 times negative 3 is negative 6. We need the charges to balance. So your charge multiplied by your subscript, in your subscript multiplied by your charge, need to equal out to 0 when you add the 2 together. Okay? Now, remember, if math is not your strong point, it is a simple drop and switch as long as the numbers that you wrote in cannot be reduced down. 3 and 2 can't be reduced. There you go. Now notice I put PO4 in parentheses. The reason I put PO4 in parentheses is because this is one thing. You are not going to change anything about it. You're not going to look at the 4. This is one thing. all you do is look at the charge of this phosphate. So since I need 2 of the phosphates, I put a 2 outside of the PO4 in parentheses to say I need 2 of this entire thing. Without the parentheses, you would say you have 42 oxygen, which would be very, 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 very wrong. Okay? So here's a basic lowdown on writing chemical formulas. Okay? So hopefully that made sense. You should remember how to do that. Now, let's do a chemical reaction, and we're going to talk about the different types first of all. We have synthesis, and we have decomposition. So I'm going to start with these two. So chemical reactions are going to have reactants and products, and the reactants are the items on the left of the arrow that are being reacted together, and the products are on the right side of the arrow. It's what you get out of the reaction. So for synthesis, if we take A plus B in a synthesis reaction, they're going to come together through a chemical reaction and form one product. This is a synthesis reaction. So we could have something like hydrogen, which is a diatom. Talk about that a little bit later. Oxygen, which is a diatom. And the two of them form a single compound. Well, we look back at our periodic table and find out that hydrogen will act as a positive cation, and oxygen acts like a 2 negative. And you can go back and look at your table. I'm not going to flip back to show that. So how would these two come together? It would be H2O. So this is our synthesis reaction. We took hydrogen gas, combined it with oxygen gas, and they came together and formed water. Now let's balance it. We have 2 hydrogen, 2 hydrogen, 2 oxygen, 1 oxygen. I put a big coefficient 2 in front of the whole water. You cannot split this. This is one substance. It is one molecule. Now, I fixed the oxygen, but I broke the hydrogen. So 2 times 2 is 4. So now on the reactant side, I need 4. So 2 times 2 is 4. So we check ourselves again. We have 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. This is the balanced chemical equation. One other type of reaction that this shows is what's called combustion. Combustion reactions occur when oxygen is a reactant by himself. All right, he's got to be by himself. And even though he's O2, he is by himself. There is no other element with him, no other substance. So if you see oxygen as a reactant, not attached to anything, it is a combustion reaction. Now let's look at decomposition. Decomposition could be something like, let's think of KClO3, okay, which is potassium chlorate. Potassium chlorate, KClO3. All right, and that's all you're given, KClO3. Well, it's going to break down. That's the only thing it can do. There's no switching, there's no combining, nothing coming together. You have to break it down. So this is a decomposition reaction. Now, the common mistake kids will make is say, oh, well, that's just potassium and that's chlorate. That would be wrong. The reason that is wrong, and I'm going to flip back to my previous slide, is because if we look up here for chlorate, ClO3 -1, that tells us that ClO3 is an ion. He's a polyatomic ion. He is not a whole compound by himself and will not be able to exist alone by himself. So this will not split into 2 ions. What's going to happen is potassium and chloride are going to branch off, and oxygen is left alone. Now, oxygen is a diatom. That means when he's by himself, he's going to bond with another oxygen. Okay, so let me point that out again. Since I can't split this into the potassium and the chloride ion, because ions are not going to hang out alone. It's not going to happen. That's why they're a charged piece. They're an ion. They need something to complete them. The Cl and the O3 are going to break apart. Okay? Chlorine's a -1 charge. Oxygen, we'll worry about him in a second. So when it goes with potassium, it becomes KCl. Then oxygen's left alone. Now, let's go through and check here and see if we're balanced. 1K, 1K. 1Cl, 1Cl. 3 oxygen, 2 oxygen. The closest number 3 and 2 have in common is 6. 3 is going to go here. 2 is going to go here. Now, that coefficient 2 not only gives me 6 oxygen, but it gives me 2 KCl's. So I'm going to come over here and put a 2 KCl. This gives me 2 KCl's, 2 KCl's, 6 oxygen, 6 oxygen, and a decomposition reaction. Okay. All right. Before I stop this video, and then I'll create another video for single displacement and double displacement and hydrocarbon combustions, I want to talk about diatoms really quickly. So I'm going to clear this slide. All right, so diatom, the prefix di means 2, and so atoms, obviously, so it's going to be 2 atoms. So diatoms are substances that will bond with themselves. So when alone, they will bond with themselves. And this comes down to something that you'll learn in chemistry called electronegativity and how they want to be full and how they want to be bonded. So the following substances are diatoms. Hydrogen, you've got oxygen, you have fluorine, chlorine, bromine, iodine. Okay, so I'm going to quickly come over here and point something out. Notice fluorine, chlorine, bromine, iodine, your halogens, they're so reactive they're going to bond with themselves. And then we had oxygen bonding with themselves, hydrogen, and our last one we have is nitrogen. Okay, so nitrogen is also going to be a diatom. It actually forms a little 7 on your periodic table. So you're going to come over here, NO all the way down, and then hydrogen's the other one. So there are 7 diatoms that you need to be concerned with, and they make that little 7. So what this means is when you're dealing with these guys and writing these out in equations, they're going to always be a diatom. So if I were to take sodium metal and combine it with fluorine gas, so sodium, he's a metal, he can hang out alone. Fluorine's a gas, he's a halogen, he is actually a diatom. Now, these two would come together as a synthesis reaction. Sodium's a +1, fluorine's a -1, so it becomes NaF. Then I would balance 1 Na, 1 Na, 2 Fs, 2 Nas, 2 Nas, balanced synthesis reaction. Notice this 2 has nothing to do with the product side in terms of the formula. Do not be fooled by that. You look at the charges to allow the substances to come together, and that's it. Okay, I'm going to create one more video that's going to talk about cationic and anionic single displacement and double displacement and hydrocarbon combustion, and then you should be able to work through the problems on the study guide 2-1.